Hi there and welcome. It's time for Physical Sciences and tani masi kunantolovelo minatinyiko wa Machapkosa, and I'm going to take you through a lesson today that takes you from grade 10 to 12, and of course at grade 10 level we're still talking waves. Grade 11 we're going to be talking about optics, and of course it will be cutting across from grade 10 to 12. And when we're talking optics, remember we're looking at light and formation of images, and we're looking at light as having that wave nature. So that's why all these are put together. Now let's have a look at what we have today. We are talking here about superposition of pulses and geometric optics. That is what the lesson is all about today. We have this term here, superposition. What does it mean? Superposition is a phenomenon that occurs when two waves cross in the same space at the same time. Okay? So when they cross at the same space at the same time, superposition will happen. So these waves superimpose on each other. Okay? So if you've got pulses that are coming together, they are going to superimpose on each other. Let's look at the result of that. When that superposition occurs, the result will be what we call interference. In other words, these waves will be interfering with each other. Okay? This interference of waves, we have got two types. Okay? So we've got two types of interference. What are they? We've got constructive interference and destructive interference. Now, when do we have constructive interference? When two waves cross each other at a point at the same time such that their crests or troughs meet at that point. The two crests or troughs reinforce each other, okay? And that results in what we call constructive interference. In other words, the result is such that the two, say this one is a crest moving that way, then there's going to be a crest, okay, moving in that direction. At the point where they meet, they are going to reinforce each other, and when they reinforce each other, you can see that the amplitudes are in the same direction there, so you're going to have the two together. We can see already what is going to happen then. So this will result in a bigger crest or trough. The size of such a crest or trough equals the sum of the displacements of the two waves. So that gives you what we call constructive interference. So there's a build-up constructive. Okay? Now, we also need to note this, that when this constructive interference has happened because the waves interfered with each other or met at that point, that constructive interference would happen only at that point when the two waves meet. The two waves obviously are going to move on, and when they move on, they are going to retain their initial displacements as they move further along their directions of motion. So the interference will happen at that point only. And it cannot be like, now it has been added, it's a bigger trough, it's a bigger crest, then it will remain like that. But as soon as the two waves separate, okay, they retain their size and position. Let's now have a look at destructive interference. Now the word can tell you, the term itself can tell you already that we're talking about something that is going to be destroyed, minimized, or becoming lesser. When two waves cross in the same space at the same time, such that the crest of one meets the trough of the other, destructive interference occurs. Okay? Now here it's situations like this. Okay? This one going that side, and another one going this side, and we're talking about a trough there. At the point where the two meet, okay, they are going to interfere destructively. In other words, they are going to reduce the amplitudes of the crest or the trough. Okay. The result is therefore a smaller crest, okay, a smaller crest or trough, or complete destruction where the vibrating medium comes to its rest position. Okay. Now, destructive interference, the same thing. The waves will retain their initial displacement as soon as they pass the point where they met. Okay, let's look at some drawing here. If you have got a crest and a crest meeting at a point, okay, this one is going that way, that one is going that way. The result will be the addition of the two, so you've got a bigger crest. If this one was 3 meters and this one was 2 meters, the resulting one will be 5 meters. Okay, and then with destructive interference, you've got this. Okay, this one say was 5 meters, this one is 2 meters, so this one you add the 2, this is a minus, that's a plus, so this, the resulting will be 5 minus 2, that will be 3 meters. Destructive interference. Okay, see you in the next section of the lesson.